All right, let's talk about when we have an equation that only has one variable. So in example 3, it says find 4 solutions for the equation x equals 6. Well, here's the thing. I don't have anywhere to plug in a y, and basically what this equation is saying, it's saying x is always equal to 6. So if we make an ordered pair, we start with 6, we can literally have any number for y as long as x is 6. So here are 4 solutions. Can anyone give me any others? You see that pattern? X is always 6. Doesn't matter what y is. So give me some more. They always start with 6. 4. Any others? 5. Okay, good. 6. 6. That's 1. What about 6? There you go. What about a fraction? 6 1/2. What about a negative number? 6 negative 100. Okay, you get the idea. So x is always 6. So now what do you think about the next one? This one says y equals negative 7. What is true about this? Give me some solutions to this equation. So y goes in the second position. Y is negative 7. You might have 0, negative 7, 1, negative 7, 2, negative 7, maybe negative 2, negative 7. You could even have negative 7, negative 7, right? Could you have 7, negative 7? Sure, as long as y is always equal to negative 7. Now, I did want to show you a little trick about the calculator. So if you have a graphing calculator or even a calculator that allows you to create a table of values, if you go to y equals, all equations in your graphing calculator have to start, all of the equations that you're going to graph in your graphing calculator always have to start with y. So I actually cannot put 6 or x equals 6 on the calculator and check it because I don't have an x equals button, but I do have a y equals. And so any equation that you have here you would clear. It doesn't actually matter what line you're on. You could start out at y1. This calculator goes down to y9. It might even go further, so it allows you to graph multiple equations. Okay, that's 10 lines. And so we can go on any line, and if I just type in negative 7, and then I go second graph, that's going to take me to a table of values. And that table of values is similar to what we were doing before. All of these x values, notice how they're all paired up with what y value? Negative 7. So y is always equal to negative 7. And I was just showing you a few examples of the ordered pairs. Now, if I wanted to go back and check the solutions to this equation, and by the way, we found out that it was easiest if we use either x is 0 or y is 0. So if you have an example where it says find a solution, find 2 solutions to the equation, what 2 values are you going to always want to use? X is 0 and then solve that, y is 0 and then solve that. If I want to plug this into my calculator, there's a problem with the way it's set up. I have to get y by itself. So if I wanted to get y by itself, let me just take a clean sheet of paper. 2x minus y equals 8. How could I get y by itself? I want to solve for y. What would be the first thing to get rid of in order to solve for y? You could subtract 2x from both sides. Don't forget that negative. I have negative y equals negative 2x plus 8. Does everybody see where I got that? Is y by itself? No. What would I need to do next? Yes, so that's a negative 1. If I divide by negative 1, everything gets divided by negative 1. I get y equals what? Right? That just changes the sign. It changed negative divided by negative is a positive. Positive divided by a negative is a negative. And if I go to my y equals, now, oops, that's not what I want to do. Y equals, I can delete that other one that I had by pushing clear. And it doesn't matter which line I'm on. Maybe I want it in pink. Okay. So I could type in, you see how it already has the y equals part. So all you're typing in is 2 and this variable x minus 8. Now I did do minus and not negative because otherwise, that could get confusing. You could do plus negative 8 if you want to, but minus 8 is fine. Now if I go second graph, that gets me to the table. Everything on my calculator that's in blue, that's above the key, is controlled by the second key. And notice there are some of my ordered pairs. So in the previous question with this problem, we were asked to circle the solutions. There's 0, negative 8. Because x is 0 and we have a y value, that's our y-intercept. If I scroll down to 4, I have 4, 0. 4, 0, that's an x-intercept because y is equal to 0. My x value is 4. Here is 6, 4. And we know that we have 4, 0, so therefore 4, 6 is not going to work out. Because when I plug in x is 4, I get 0, I don't get 6. So we don't have that one on our table. But truth be told, there's an infinite number of ordered pairs. And if I kept plugging in x values, I would get out a corresponding y value. I have an infinite number. This is only showing me the integer values. Remember we were talking about the idea of integers? I could change the table. I won't get into that right now, but I could change the table so that I could come up with fractions if I wanted to. I could plug in any value of x, and then back here, if I scroll up in my table, I'm getting negative values for x as well. So that's very helpful to generate a table of values. In fact, for the next problem, I want to use the table on my calculator. Why not? Okay, so I'll just show you. We're converting Celsius to Fahrenheit in this formula, and we've talked about this formula before. I could, of course, plug that 50 in, and let's just show how we would do that, and then I'll show you on the graphing calculator as well. F equals 9/5. Since we know it's 50 degrees Celsius, we're plugging in the 50 plus 32, and then we could solve for y, or this is f, really. Okay, so we have 50 over 1. 5 goes into 50 10 times. We get 90 plus 32, which is, anyone know? 122. So that means if you have 50 degrees Celsius, that's equivalent to 122 degrees Fahrenheit. So that's what we're solving here. And if I wanted to do this in my calculator, I could rewrite this as y equals 9/5 x plus 32. So I'll go into my graphing calculator. I can clear out any equation that I have. I can type in, how do I type in a fraction 9/5 on the calculator? Yeah, use the divide. 9 divided by 5 is 9/5 times x plus 32. And if I go second table, I get this table of values. Now it can be really hard because I want to find 90 and negative 90. I'm going to have to scroll a lot. And actually, this is where your table setup could come in handy. I would suggest plugging it in and then using your calculator to check, just so that you have a way to verify your answer. So if I want to, I can go second window, and right above window it says table set. That's a table setup. Where do we want our table to start? Well, I want it to start at 0. But I don't want to have to scroll all the way down to 90. So this triangle next to the table means the change in the table. How do you want the table to count? Do you want it to count by 1? Maybe you want it to count by 10, and then you can get there faster. And then you can go enter, 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 and then you can go back to the table. And you see what happened now, my x values are actually counting by 10. So I don't have to scroll all the way down to 90, 90 times. I can scroll directly down to 90, and I can see that I get 194. But of course, you want to show the work, degrees Fahrenheit. I would suggest you show the work. if I go back to 50, I can check to see, oh yeah, I did my math correctly because I get 122, and that's what my table says. And then if I scroll up, I'm going to get to my negative numbers, and I'm going to scroll up to negative 90, and I'm going to get negative 130 degrees Fahrenheit. Okay, so that's just another way to use the calculator to help support your work and check your answers. Any questions about that? Okay, let's go on to the next one.